Euler continued to investigate properties of numbers, specifically the distribution of prime numbers. One important function he defined is called the phi function. It measures the breakability of a number. So given a number, say n, it outputs how many integers are less than or equal to n that do not share any common factor with n. For example, if we want to find the phi of 8, we look at all values from 1 to 8. Then we count how many integers 8 does not share a factor greater than 1 with. Notice 6 is not counted because it shares a factor of 2, while 1, 3, 5, and 7 are all counted because they only share a factor of 1. Therefore, phi of 8 equals 4. What's interesting is that calculating the phi function is hard except in one case. Look at this graph. It is a plot of values of phi over integers from 1 to 1,000. Now, notice any predictable pattern. The straight line of points along the top represent all the prime numbers. Since prime numbers have no factors greater than 1, the phi of any prime number, p, is simply p minus 1. To calculate phi of 7, a prime number, we count all integers except 7, since none of them share a factor with 7. Phi of 7 equals 6. So if you're asked to find phi of 21,377, a prime number, you would only need to subtract 1 to get the solution, 21,376. Phi of any prime is easy to compute. This leads to an interesting result based on the fact that the phi function is also multiplicative. That is, phi a times b equals phi a times phi b. If we know some number n is the product of two primes, p1 and p2, then phi of n is just the value of phi for each prime multiplied together, or p1 minus 1 times p2 minus 1.